Welcome. Today we're going to learn to factor by grouping. Before we actually get into the actual factor by grouping, I need to help you understand the concept of factoring out a set of parentheses from two terms. So let's do an example. What I mean by an example is let's factor 3x plus 6. And if I ask you to factor out the greatest common factor, we look for a factor of 3 and a factor of 6 that are in common. Both have a factor of 3. So I factor out the 3 parentheses x plus, and then I'm dividing out the 3, so it's x plus 2. An even better way to kind of write that is to think of this as 3 times x plus 2 times 3. Then hopefully you can see that we both have that factor of 3. I'm going to factor out the 3, right? Take out the 3, take out the 3. What's left is the x plus 2. Well, now I'm going to even do that more generically. And what I mean by more generically is I'm going to do an a times an x plus a 2 times an a. Okay, so a is some unknown value. Okay, well, again, both of these terms have an a, so I could factor out the a and leave the x plus 2. And there's a single a. If I distribute in the a, I get the 2 a's back. Now you're like, where is he going with this? Mr. Thorson, I don't understand where you're going with this. Well, now what I'm going to do is I'm going to do this. I'm going to do a set of parentheses times x plus 2 times a set of parentheses. And what I'm going to say is whatever's in those parentheses are the same. I don't care what's in them. If you want, put an a there. Put an a there. I don't care. There's some parentheses, something in the parentheses. Again, I'm going to factor it away from the x and the 2. So if I factor away that a, that's in parentheses, and I put parentheses, what's left? X plus 2. Now, I want you to look up here and notice that I actually had 2 sets of parentheses up here. Down here, I have 2 sets of parentheses again. And this 2 sets of parentheses became 1. And the stuff that was on the outside became 1. So I'm going to do this one more time, except what I'm going to do is I'm going to replace the a with even something else. I'm going to do parentheses, and I'm going to do something like, I don't know, x plus 5 times this x plus 2 parentheses. Again, I'm going to make an x plus 5. So what I'm hoping you see now is this parentheses, x plus 5, and this parentheses, x plus 5, look exactly the same. And I'm going to pull them away or factor them away, that x plus 5 away from the x. So I do a parentheses, leave the x, pull out the x. So I'm pulling this in a sense out front as a single x plus 5, and it leaves the 2. So if you'll notice here, I had this parentheses times an x plus this parentheses times a 2. And the parentheses were the same, I pull it out in front to make a single x plus 5. And what's left is this x plus 2 that goes in that second set of parentheses. So now let's actually do a problem that you're going to see in the IXL lesson. Okay, what you're going to see is you're going to see something like this. 2n cubed plus n squared plus 14n plus 7. Okay, now you're going to be asked to factor this. Now this isn't a quadratic, this is a cubic. So how do we factor it? Do I do 2 numbers and multiply to give you 7, but add to give you 14? But what about the 1? What about the 2? What we do is we factor by grouping. And what we mean by that is we're going to cover up the last 2. We're going to group the first 2 things together and just say what's in common with the 2n cubed and the n squared. Well, both of them have an n squared. So what I'm kind of like doing is I'm breaking this up. I'm going to put a line down here and I'm going to group the first 2 terms together and say those first 2 terms have have an n squared in common. And n squared, now I'm going to factor that n squared out. If I factor out an n squared, I'm left with a 2n. And I factor out an n squared. Be careful here. If I divide out an n squared, what's left? Remember, always something's left. 1 is left. Then what I'm going to do is I'm going to look at these second terms and do the same thing. I'm going to ignore the front now, and I'm going to say, what's in common with the 14n squared and the 7? Well, they both have a factor of 7. So what I'm going to do is I'm going to factor out, now don't forget the plus, and I'm factoring out a positive 7. So I'm going to factor out a positive 7. And what am I leaving? Well, 14n divided by 7 is 2n. 7 divided by 7, remember, something's always left, a 1. Now, if you've done things correctly, this parentheses should look like this parentheses. And it does, 2n plus 1, 2n plus 1. I'm going to factor the 2n plus 1, the parentheses. I'm going to take this and factor it out front as a single 2n plus 1. So I took that away from the n squared term. I took that away from the 7 squared. And now I'm going to write what's left, an n squared plus 7. So I have a 2n plus 1 times an n squared plus 7. And I'm done. I factored it. Let's do another one. Let's do 4m cubed plus 9m squared plus 4m plus 9. Again, not a quadratic. This is a cubic. I'm not sure how to factor this. Well, the way I factor it is I'm going to ignore the last two terms and I'm going to say what's in common with the 4m cubed and the 9m squared. Well, both of them have an m squared. So what I'll do is I'll factor out an m squared from this first and second term. 4m cubed divided by m squared will leave a 4m. 9m squared divided by m squared leaves just 9. Okay, now that I factored out something from the first two terms, I'm going to ignore those, and I'm going to look at the last two terms and say, well, what's in common? Well, there's nothing in common with a 4m and a 9. No common factors between 4 and 9. Well, or is there? There's actually one common factor, and I just said it, one common factor. It's 1. So if you don't see anything in common, factor out a 1. So what I'm going to do is I'm going to divide out a 1, and I'm going to divide out a positive 1, like this. And if I do that, look what's left. Well, what's 4m divided by 1? 4m. What's 9 divided by 1? It's 9. Look, these two parentheses are the same. Because you're going to ask, why did you do that, Mr. Thorson? Why did I factor out a 1? Well, I want another set of parentheses that's times something where that parentheses is the same as this set of parentheses. And I already have it, 4m plus 9. So I had to factor out a 1. Now again, what I do is I take that parentheses, and I factor it away from the m squared and the plus 1. I factored out in front. So I factor that 4m plus 9 in front, so I do another set of parentheses in front of an m squared plus 1. And I factored it to two sets of parentheses. It's factor by grouping. Let's do another one. Now, because the reason we're doing this is because a lot of times we get polynomials that aren't quadratics. Watch this one. I'm going to throw in another variable. Plus 3y minus 20z minus 30. So here we have one that's not even a quadratic. There's not even a squared in there. No cubics. But does it factor? It does. What we're going to do is we're going to ignore the last two terms for a minute. What's in common with the 2yz plus the 3y? Well, there's a y in common. So I'm going to factor out this y and this y. And I'm going to factor it in front, leaving the 2z and leaving the 3. Now I'm going to ignore those front terms, and I'm going to look at the last two terms. What's in common with the 20z and the 30? Well, there's a 10 in common. And look at the sign. There's a negative 10 in common. The reason I want to factor out a negative 10 is, remember, I'm shooting to get an expression that has a 2z plus 3 left in parentheses. So I'm going to want this second term to become a positive, and I want the first term to become positive. So I'm going to factor out a negative 10. Now, if I've done this right, when I divide out a negative 10, I better be left with a 2z. Well, what is 20z, negative 20z divided by negative 10? It's 2z. z. What's negative 30 divided by negative 10? It's plus 3. I get the exact same set of parentheses. So now what do? I take this, I pull it out in front as a single 2z plus 3, because I factored this away from the y and I factored this away from the 10. So what's left? A y minus 10. And you're done. Does that make sense? Should I do one more really quickly? Really quickly. 6f squared g minus 12f squared minus 21f times g plus 42f. Wow, that looks confusing. Lots of f's and g's, and there are squareds. But again, process is the same. I'm going to ignore the last two. What's in common with those first two terms? A 6 and an f squared. So I'm going to take a 6 and an f squared. That's that. And that's the f squared. And I'm dividing this by 6, right? So I'm going to be left with a g minus 2. Then I'm going to ignore those front terms and look at the last two terms. What's in common? Well, I got 21 and 42 have I believe, a 7 in common. So I'm going to factor out a 7. They both have an f, so I'm going to factor out an f. And it looks like this is negative, this is positive, but in here it's positive, negative, so I'm going to factor out a negative 7f. When I factor out a negative 7f, I'm left with a 3g. When I factor out a 7, I'm left with a 6. Oh, there's more in common. Do you see what I did here? 21 goes into 42. I noticed the 3g and the 6 are not the same as the g minus 2. There was something wrong, but then I noticed, oh wait, look. The 3 and the 6 have a common factor of 3, which would leave it as a single g and a 2. And then I also dropped a sign. I factored out a negative 7. So let's actually factor out a negative 21 g, or f I mean. Now that's going to be a 1g. That's going to be, remember, a negative 2. Now it's the same. So that actually even helped me find that I could factor out more than just 7. I could factor out 21. So now what I'm going to do is I'm going to take this g minus 2 and this g minus 2 that are the same. I know it's kind of messy. That's a 1g minus a 2. So I'm going to factor that out and give myself a g minus 2. That's the two parentheses pulled out as a single. What's left after I factor out the g minus 2? A 6f squared. What's left of this term as I factor out the g minus 2? A minus 21f. And there is my factored form of my expression. Actually, I can even factor more, because I just noticed the 6 and the 21 have a 3 in common. So I can factor out a 3. I should have looked up here and noticed that 6, 12, 21, and 42 all have a factor of 3 and a factor of f. So remember the first rule of factoring, which I forgot? Look for anything in common with all the terms. I should have factored out a 3f and then wrote a 2fg minus 4f minus 7g plus 42 divided by 3 is 14. And then factored that by grouping with the 3f in front. But now I got to take the time to write out a 3f here, change that to a 2f, and change this to a 7 with no f. And that got very, very messy. I had to factor out a 3f, then I had the g minus 2, and then I had this 2f minus 7. There's the fully factored form. You can't quite see that. I'm sorry that you weren't able to see that. But again, I kept catching my mistakes. I noticed that 6f squared and 21f had not only a 3, but also a f. Remember, the first rule of factoring is look for anything that's in common with all your factors. Again, if this confused you, this last one, ask me to do it for you again in class, and I absolutely will.